urban and regional planning as a profession has been in this country for some time, and to be an urban and regional planner, students at the secondary level must choose subjects from geography, mathematics, technical drawing, as well as other subjects. But geography is very important. The maths and English are also very important. You can choose from government, economics to add to it. Now, what are the demands for being an urban and regional planner? Normally, the courses we have, you either do the urban and regional planning course in the university or in the Polytechnic. Now, apart from that, there's another route for those who do not or who could not go through the formal education. They could do the professional examination. But be it as it may, at the end of the day, either you go through the university, the Polytechnic, you must be a registered urban and regional planner to practice urban and regional planning in Nigeria. Now, the demands in urban and regional planning is just like any other profession. Now, as a planner, we uphold ethics of the profession, and that's why members are inducted. It's not a cult, but we have to uphold that ethics of integrity, and we must be sound in every area of the profession. Now, there are aspects of urban and regional planning students have to go through, and that has to do with they have to be taught in the theory and also in design and the practicals. It's a very intensive course and a very intensive program, but I think when you finish the course, you have, so much opportunities. You can work in oil companies, you can work in the bank, in the properties section, you can work in an architectural firm, you can work with governments. It's a very lucrative course, and I feel I'm encouraging any secondary school students to look into taking this profession.
This is the showroom of the Department of Agricultural Engineering Technology. It has on display a wide range of students' projects, past and present. Interestingly, the department places a lot of emphasis on post-harvest processing and preservation. That is why, according to Dr. Rufus Rotimi, students have been made to produce machineries and fabrications that will remove or cut to the barest the drudgery usually faced by our farmers and the losses of post-harvest of agricultural produce.
Post-harvest. Talking about equipment, and you have mentioned post-harvest, and well, let me just tell you something about agricultural production. There is the pre-harvest, that is operations that has to do with sowing the land, planting the crop, taking care of the crop until it is matured. All those periods constitute pre-harvest. Harvest is removing the thing from the field and taking it to the barn. So post-harvest is whatever happens after you have harvested. Well, majorly what happens in post-harvest is processing the crop, storing the crop. Well, a lot of the projects here are also into post-harvest. The pre-harvest aspects are also here. Like that equipment there is for harvesting, that one that looks like a knife. There are other ones which you may see later. Agricultural engineering is basically applying engineering to solve agricultural production problems. Here we have a lot of inventions, but for today we are hoping to show you majorly 3 of our students' projects. We will begin with the feathering machine. Well, for production of poultry, especially the one that is not up to the large scale, sometimes removing the feather is a problem. So we have a machine here which one of our students fabricated, and it's for removing the feathers. So it is right there. We have also a version of the yam pounder. You might have heard of that. Some years back, somebody here in our country invented that. There are other versions, but we have our own version here. If you know what has been going on yam pounding, that patent was stolen from Nigeria here, and a company outside the country developed, and we are importing it from them. So we have our own version here.
Jimo Olayinka and Adewale Adeyemi are both HND 1 class students. They present their chicken defeathering and solar oven cooker projects respectively.
The title of the project is the feathering machine, and what it does was to remove the feather from the poultry chicken, or basically chickens, the fully matured chickens. So that is the basic operation, and it is not really manually operated. It is powered by electric motor, power horse. And this thing here, they stand as a mechanism for removing the feather from that chicken after it has been sinked into a boiled hot water. Then it can defeather like 2 to 3 chickens at a time in 5 minutes. After coupling the electric motor to the machine, and it enhances the rotational movement of the bearing and all that. So as you can see, what is really here on the ground, which is attached to the bearing, it will be moving the chicken. As it is moving, the stuff we are having here, this rubber, will stand as a mechanism for removing the feathers from the chicken.
Cost, yes, but if you want like 10 units,
yes,
does that affect the price?
It doesn't really affect the price, because we are really basically on the materials, on the items, and the price which comprises. It might not really basically on, maybe probably because we're doing it on a large scale. So we are going to add the materials, everything, and the cost of production.
Now, this seems to me like a prototype. Is it possible to make something bigger that can say the feather about 15, 20, 100 chicken at a time?
Sure.
Based on this same principle?
Yes, sure. In engineering, we can develop that, because this is also a development. It is an innovation, as in to make change. It's a design. You understand? To ease the operation of removing feather from fowl, so we can make it on a very big and a large level. This is the bearing. This is how it moves, and while it is moving, this thing is the rubber head is removing the feather. So that is how it works. This is where we couple the electric motor, and this is frame structure. This is what really is differential that supports the machine to stand firmly on the ground. This frame structure that support the machine to stand firmly on the ground. These are bolts and nuts. And these are the rubbers. They are made of metals. This is rubber, mild steel. We have basically mild steel, which is were used, and then we have the bearing, the rods, and the frames, which are also metals, which are made for the machine. But let me say the cost of everything might probably 80,000.
This project is about solar oven. The materials used for this project are very cheap and commonly available in our environment. The materials include the foil paper, which is silver in color, a disc, and in it here we have a thermometer to measure the temperature, and a stand on which we can place the material or the thing we want to heat up. This is how it operates. The radiation from the sun falls on the disc here, and when it falls on the disc, it is being diverged to this mirror here, and we have a mirror here that converge all the diverted rays, because when the radiation is heated on the disc, it scatters, and the radiation of the sun that is coming will fall on the disc here, and it will be diverged to this glass here, and on the glass we have a mirror, a minute mirror that will converge all the the radiation that is coming from the sun on the disc to the mirror to a point. The reason being that the rays, the radiation that will fall on the disc will be scattered, but this mirror will converge everything together to a point, and this mirror will now transmit the heat into this black body. This is known as a black body, and black body is able to hold heat radiation for a long time. It absorbs any heat placed on it. And when the black body absorbs the heat, it keeps the heat and warm it up. And when we tested this project, its temperature rises to 60 degrees centigrade. And because of the environment in which we are, it can be improved to perhaps 100, even more than that. And we tested it with egg. We boiled it on it, and it boiled very well. And we also boiled water on it to an appreciable degree. And this project is an ongoing one, which can be improved to generate heat. And it is very useful for everybody. Because of the electricity problem we have in our country, in rural area, even in urban city, this can be used in the household, in the industry, and perhaps with the farmers as well. In household, we can use it to, the housewife can use it to heat up the environment, to cook as well. In the farm, it can be used to dry up our crops, to preserve them for a long time. And even in hotels, it can also be used as a sort of generating heat to appreciate what they are having in their environment and to make use of it. And as I said earlier, it's an ongoing project which can be improved. And doing that, you can increase the temperature to perhaps more than 100 degrees centigrade. The basic principle is very easy. The sun, we all know that it generates energy. And the energy it generates, we convert it to heat energy. As I said earlier, the radiation will fall on the discs. And the function of this minute mirror is to convert all the diverted energy, the rays, to one point, so that it can generate the heat at one point, so that it won't be scattered. If it's scattered, we won't have a uniform heat, and it won't heat up what is inside the black body. So the mirror here will converge all the rays to one particular point, and it will heat up anything that is placed inside the oven.
In the HND2 class, Miss Otisi Justina chose to present the Laspotec version of the yam pounder, while Vivian Macaulay presents a group project in the form of a cowpea thresher.
This machine is called yam pounding machine. The components include the electric motor, the connecting rod, the bearing, the stainless steel, the stand, the switch, the valve. Then inside the pot, which is made of the stainless steel, we have the angular rod, which is being connected to the shaft. So when this is the cable which is connected to the electricity. First of all, before our machine work, we have to boil our yam, whether by stove or with the use of gas cooker. After the yam is boiled and it is fully boiled and you know that it is soft, then we do what? We open our pounding machine. We make sure it is cleaned, free of dirt and every kind of organisms. So we pour our yam, our boiled yam in it. We cover very tight with our bolt, very fist tight to prevent escape of steam. Escape of steam from either side because it is pressure valve. So we plug our cable, then we on it. Then our switch, we on it too. Then the electric motor transfer it converts the energy. Then it begins to rotate. It gives the power here. Then the shaft begins to rotate. Then it also moves the connecting rods here, which is in rectangular shape. First of all, it begins to blend it. We should remember that our pot is heat sealed to prevent any form of escape of steam, to make sure that the steam is being maintained in the pot. So the shaft begins to rotate, and first of all it begins to blend the yam. After blending, then they begin to form some kind of pastry sauce, pastry kind of material. Then after it begins to make them in uniform. So this takes about 5 minutes before the completion of pounded yam. We have different kind of stainless steel. This one is much more expensive. So it's because of this is an edible substance. That's why we use the stainless steel material to construct the pots.
The purpose behind the construction of this machine is to help in reducing labor pains that women particularly go through in the process of getting the beans ready for food. And we know that here in Nigeria, beans is one of the major source of protein, aside from meat and other things. And a lot of people cannot actually afford meat. So to make it easier for the beans to be able to get to our table in time, we're looking at all the problems that women go through in order to be able to put these beans on the table for us to eat. That was what made us think about constructing this machine you see here. This is actually a cowpea thresher. It's being operated with the aid of this engine here. The engine has a power of 5.5 horsepower. The working principle is this, that actually the part, this is the hopper. In here we have a threshing drum, and it has a sieve, and also another hopper here, the outlet where the bean comes out from. When the engine is turned on, the rotation from the power from the engine also helps to agitate this, which now helps the hopper inside to turn. Now the beans is poured in through this. As soon as the beans is poured in, it has to be covered so that the pressure from there doesn't push it out again. Now the threshing drum rotates with the help of the engine that is running. As it rotates, the drums will beat on the beans to help dehusk the beans. By dehusking, we mean just to remove the beans, separate it. Now because it has a blower, the blower is going to do something. It's going to blow off the chaff. Because the chaff are a lot lighter than the beans is heavier. So the beans will drop through the holes. Now the sieve has holes. Actually, we graded it with 7 mm. That's looking at the sizes of the beans we have. So as it drops, we can collect it with our bag down here, and the chaff will be blown off. So that's just a simple working principle. This is a mild steel. We made use of mild steel. The thickness is about 3 mm. We drilled the holes of this base, considering the fact that the beans comes in different sizes. So we had to drill it, and like I said earlier, we used the 7 mm to drill this. Without this pulley, really, the whole machine is useless, because that's what connects the power from the machine to the threshing drum. The diameter of the whole, the same mild steel we use in the construction of the whole thing, that's what we also use for the chutes, as well as, but we had to use a thicker, this we usually call it angle iron, because that's what holds, so that when this is rotating, the power doesn't throw away the machine. So we had to consider the weight too in getting the size of that. Okay, so I'm going to open the hopper so I can pour this in, and Emmanuel here will help us turn the machine on. Okay, so we're doing that. All right, so Emmanuel, you can turn it on.
The Central Wood Workshop is no doubt in the Civil Engineering Technology Department of the Laspovideo. The unique thing about this workshop is that it serves as a hub that services all the engineering departments of the School of Engineering. On offer at the Wood Workshop are Eric Adesoji's computer table and another group project, which is construction of a concrete slab as presented by Banjo Oluwaseyi. Both projects are still under construction.
This is computer table. So the name of the wood is Danta wood. Then the botanical name is Lacedonia papaverifera. That's the botanical name of the wood. Then this wood, the normal measurement of the plant is 12 inches. Then we have to use butt joints to expand the wood. So that's the reason why we have up to 15 inches. Then this one is the place that the drawer for the keyboard. Why this one I'm preparing is the top of the computer table. This is the side for the keyboard. This one is for the CPU. This one is for other instruments, other computer items. So the top of the table, we have the monitor. This is the top of the computer table. After placing it, I'll nail it. Then I'll use lacquer, neutral polish to do the finishing. I started this yesterday at about 10:15 a.m. So this is how far it has gone. So maybe for up to 7,000 naira, the normal cost for the project.
This is the framework, and this is the reinforcement bars, and it's dimensioned. This is the binding wire. We dimensioned it to 150 mm before tightening the binding wire, and now you have to raise it up before pouring concrete on it. And after that, we leave it for the second day. Will come to pour it water, which we call curing in building language. After that, after 24 days or 31 days, they will remove the formwork, and it's already set. Then we'll do the plastering. That's it.